Welcome and thank you for joining us today. For those who may be new to Actiphy, we've been focused on imaging-based backup and recovery across physical, virtual, and cloud environments for a long time. And today we're going to talk about how that applies specifically to Proxmox. This session focuses on running Proxmox in real production environments. Specifically, how to protect systems, recover quickly when something goes wrong, and migrate safely as platforms change. We're not here to do a feature walkthrough. Instead, we'll talk about operational reality, what happens during outages, during platform transitions, and when recovery actually matters. By the end of this session, you should have a clear understanding of how ActiveImage Protector fits into a Proxmox environment and how it helps provide consistent backup, recovery, migration across physical and virtual cloud systems. Let's begin with a question many IT teams are quietly asking right now. Why are so many organizations evaluating alternatives to their current virtualization platforms? For many, the answer starts with cost. Over the past few years, virtualization licensing models have shifted significantly. Pricing structures have changed, bundling requirements have evolved, and long-standing assumptions about renewal costs no longer hold true. For MSPs and enterprise IT teams alike, this creates a real uncertainty. Infrastructure planning depends on predictability, and when licensing becomes volatile, it affects budgeting, contract renewals, and long-term strategy. Proxmox has entered that conversation not simply as an alternative hypervisor, but as a platform that restores cost transparency and operational control. This isn't about chasing something new. It's about stabilizing infrastructure decisions in an environment where licensing models are changing faster than many organizations expected. And that shift in mindset is what's driving many teams to take a serious look at Proxmox. Cost is often the catalyst, but once organizations begin evaluating alternatives, the conversation usually expands beyond pricing. Many IT teams are increasingly uncomfortable being tightly coupled to a single vendor's roadmap, licensing model, or ecosystem decisions. When your virtualization layer becomes dependent on a single company's strategy, your infrastructure's flexibility narrows. That's where vendor independence starts to matter. Proxmox is built on open technologies, primarily KVM and open source components, which give organizations far greater visibility and control over how their platforms evolve. There's no proprietary lock-in at the hypervisor level. For MSPs, this independence translates into flexibility. You're not building client infrastructure around assumptions that could change unexpectedly. You're building on a platform that's transparent, standards-based, and adaptable. And that shift from dependence to control is often just as important as the cost savings themselves. Of course, cost savings and vendor independence only matters if the platform itself can run real production workloads. That's an important distinction. Proxmox is not a niche hypervisor or an experimental project. At its core is KVM, the same kernel-based virtualization technology that powers large-scale enterprise and cloud environments around the world. KVM has been battle-tested for years. It supports live migration, high availability, clustering, and the performance characteristics organizations expect from modern virtualization. What's changed recently isn't the technology's maturity, it's the level of adoption. More MSPs and enterprises are recognizing that Proxmox delivers the reliability and performance they need without the constraints they have been experiencing elsewhere. So when organizations evaluate Proxmox today, they're not taking a risk on something unproven. They're adopting a mature virtualization stack with a management layer designed for production use. And once that decision is made, the next question becomes critical. How do we protect it properly? Now that we've looked at why organizations are moving to Proxmox, let's talk about what happens once it's deployed in production. At its core, Proxmox is built on KVM, a mature kernel-based virtualization technology that's been powering enterprise and cloud environments for years. This isn't experimental infrastructure. KVM supports clustering, high availability, live migration, and the performance characteristics required for real production workloads. For MSPs and enterprise IT teams, that maturity matters. When you're running customer workloads, internal line of business systems, or mission-critical applications, the virtualization layer must be stable and predictable. Proxmox, built on KVM, delivers that foundation. And that's why we're not talking about lab environments or pilot projects here. We're talking about real production systems. Proxmox today is not confined to small deployments or niche use cases. It is actively used in enterprise data centers and MSP-managed environments around the world. Organizations are running line-of-business applications, databases, web platforms, and infrastructure services directly on Proxmox clusters. For MSPs in particular, Proxmox has become increasingly attractive because it supports multi-node clustering, centralized management, and predictable performance, all without imposing rigid licensing structures. What we're seeing isn't experimentation, we're seeing production adoption. And that's an important distinction. When a platform moves from alternative to actively deployed in live environments, expectations change. Downtime tolerance drops, recovery expectations rise, and operational discipline becomes critical, which brings us to the next point. When Proxmox is running production workloads, recovery is no longer theoretical, it's operational. In production environments, failures are not if scenarios, they are when scenarios. Hardware fails, administrators make mistakes, updates introduce instability, and ransomware continues to target infrastructure. When that happens, what matters most is not just that backups exist. What matters is that recovery is predictable. Predictable recovery means you know how long the restoration will take, you know the system will boot, you know dependencies will come back online cleanly. You know that the process works because it's been tested. In virtualized environments, that predictability becomes even more important because a single host or storage issue can affect multiple workloads simultaneously. So once Proxmox is running in production, the conversation shifts. It's no longer about virtualization features, it's about recovery confidence. And that leads directly to the next topic, understanding where Proxmox native backup capabilities fit and where broader protection strategies are required. Proxmox includes its own native backup solution, Proxmox Backup Server. It is purpose-built for protecting Proxmox virtual machines and containers. For organizations running exclusively within a Proxmox ecosystem, this offers tight integration and efficient VM-level backup workflows. Backups are optimized for Proxmox storage formats, and management remains closely aligned with the hypervisor environment. That tight coupling is intentional. It's designed to provide efficient protection within a Proxmox-only infrastructure. And for many deployments, that works very well. However, as environments evolve and become more complex, it's important to understand both the strengths and limitations of a platform-specific backup approach. Let's take a closer look. Proxmox Backup Server is designed specifically for Proxmox environments. That focus brings efficiency. Backups are optimized around Proxmox virtual machines and containers. The integration is streamlined, deduplication and storage handling are tuned for that ecosystem. When your environment is entirely Proxmox-based, that specialization can be a real advantage. But that same specialization also defines its scope. It is intentionally focused on Proxmox workloads. It is not designed as a universal backup platform for mixed hypervisors, physical systems, or cross-platform migration scenarios. And for many organizations, especially MSPs, environments are rarely single platform. Virtualization stacks evolve, legacy systems remain, platform transitions happen, which leads to the key boundary we need to discuss next. Proxmox Backup Server is designed to protect Proxmox environments, and it does it well, but it is not intended to serve as a cross-platform recovery or migration tool. If an organization needs to move workloads between hypervisors, restore systems to physical hardware, or recover into a cloud environment, that falls outside the primary design scope of a platform-specific backup solution. And this distinction becomes especially important during periods of transition, when organizations migrate from VMware to Proxmox, when physical systems are virtualized, when workloads are moved into the cloud. The backup strategy must extend beyond a single hypervisor boundary. This isn't about replacing one tool with another. It's about recognizing that as infrastructure becomes more dynamic, protection strategies must become more flexible. And that's where the enterprise backup gap begins to appear. Modern IT environments are not static. Platforms change. Organizations migrate from one hypervisor to another. Hardware is refreshed, workloads are rebalanced, cloud adoption expands. Each transition introduces operational risks. During a platform migration, for example moving from VMware to Proxmox, there is often a temporary period where systems exist in multiple states. Some workloads are still on the old platform, some are already on the new one, and some may be in transit. If backup strategies are tightly coupled to a single platform, those transitions become far more complicated. You may need multiple backup tools, multiple recovery workflows, multiple verification processes, and complexity is where risk grows. The backup strategy must remain stable, even if the infrastructure underlying it changes. That's the gap many organizations discover during transitions, and it becomes even more visible in mixed environments. In reality, most production environments are mixed. Even after adopting Proxmox, organizations often continue running other hypervisors. VMware may still exist in part of the infrastructure, Hyper-V may support certain workloads, physical servers may still run legacy applications, cloud instances may support specific services. Very few environments are single platform. And when multiple platforms coexist, backup complexity increases quickly. Different tools, different retention models, different recovery procedures, different verification processes. For MSPs, this fragmentation doesn't just increase technical overhead, it increases operational risk. Technicians must remember which tools apply to which workload. Recovery procedures may vary depending on where the system runs. Documentation becomes more complicated, training becomes harder. And the more complex the recovery becomes, the less predictable it is under pressure, which brings us to the core requirement. When environments are mixed and platforms are evolving, one principle becomes essential. Recovery workflows must remain consistent. It shouldn't matter whether a system runs Proxmox, VMware, Hyper-V, physical hardware, or in the cloud. The recovery process should follow the same logic, the same validation steps, and the same operational expectations. Consistency reduces cognitive load. It reduces the chance of mistakes during an outage, it reduces the complexity of training for MSP technicians, and it dramatically improves recovery confidence. Under pressure, simplicity wins. If every platform requires a different recovery tool or different workflow, incident response becomes fragmented. But if backup and recovery model remains consistent, regardless of where the workload runs, the infrastructure can evolve without increasing operational risks. That is the core of the enterprise backup gap, and that's precisely where ActiveImage Protector fits. ActiveImage Protector is not tied to a specific hypervisor. It operates above the hypervisor layer. That distinction is important. Rather than tightly integrating with a single virtualization platform, ActiveImage Protector protects the workload itself, the full system image, regardless of where it runs. Whether the system is hosted on Proxmox, VMware, Hyper-V, physical hardware, or even in a cloud environment, the protection model remains the same. This architectural separation is intentional. It allows the virtualization platform to evolve independently of the backup strategy. You can change hypervisors, you can migrate workloads, you can modernize infrastructure, and the recovery model remains stable. By sitting above the hypervisor layer, ActiveImage Protector provides platform independence without interfering with the virtualization operations. And that's what enables consistent protection across mixed environments. ActiveImage Protector is not intended to replace Proxmox or Proxmox Backup Server. It complements them. Proxmox provides the virtualization platform. Proxmox Backup Server provides native VM-level backup within that ecosystem. ActiveImage Protector extends protection beyond the boundaries of a single hypervisor. It enables cross-platform recovery, it supports migration scenarios, it maintains consistent workflow across physical, virtual, and cloud systems. In environments that are exclusively Proxmox, the native tools may be sufficient. But in mixed environments, or during periods of transition, an additional platform-independent layer of protection becomes valuable. The goal is not duplication, the goal is flexibility. Together, these tools can coexist, each serving as its intended role. And that complementary approach is what allows organizations to modernize infrastructure without increasing risk. Ultimately, the value of ActiveImage Protector in a Proxmox environment lies in its consistency. Consistency across platforms, consistency across migrations, consistency across recovery scenarios. Whether a workload runs on Proxmox today, moves from VMware tomorrow, or is restored into the cloud next year, that protection model does not change. The same image-based backup, the same verification process, the same recovery workflow. For MSPs, this consistency simplifies training, documentation, and incident response. Technicians don't feel the need to switch mental models depending on the platform. Recovery procedures remain predictable, even when infrastructure evolves. And that is the real advantage of sitting above the hypervisor layer. The infrastructure can change, the recovery strategy does not. ActiveImage Protector provides native support for Proxmox environments. Because Proxmox is built on KVM, ActiveImage Protector leverages that foundation directly. This is not a workaround, it's not a generic integration, and it's not dependent on unsupported APIs. The architecture recognizes Proxmox as a KVM-based virtualization platform and is designed to reliably and consistently protect workloads running within that environment. For MSPs and enterprise IT teams, this means Proxmox can be treated as a first-class citizen within the backup strategy. There's no special handling required, no secondary tool chain, no separate operational model. The protection works within the Proxmox ecosystem while remaining platform independent, and that balance is intentional. Support for Proxmox is not positioned as experimental or secondary. It is designed with production workloads in mind. This means predictable backup performance, consistent recovery behavior, and the ability to scale alongside clustered Proxmox deployments. Production environments demand more than successful backups. They demand reliable scheduling, verification, clear recovery paths, and operational stability under load. ActiveImage Protector is built on image-based protection, which has long supported enterprise-grade environments across physical and virtual infrastructures. That same production discipline applies to Proxmox. When workloads are business-critical, protection must be equally robust, and that design philosophy carries directly into the Proxmox integration. One of the most important aspects of Proxmox support in ActiveImage Protector is this. It uses the same core architecture that protects other supported platforms. There is no separate Proxmox-specific engine, no alternate recovery framework, no isolated feature set. The same image-based protection model that supports physical servers, VMware, Hyper-V, and cloud environments applies here. That consistency matters. It means Proxmox is not treated as an edge case. It is integrated into a unified protection architecture. For MSPs, this simplifies operations dramatically. You're not maintaining separate knowledge tracks for different hypervisors, you're not training teams on fundamentally different recovery processes, and you're not introducing architectural fragmentation. You're extending an existing proven protection model into Proxmox. And that is what allows infrastructure to evolve without forcing a complete rethinking of your backup strategy. In Proxmox environments, ActiveImage Protector supports agentless backup. That means there is no requirement to install backup agents inside each virtual machine. No additional software is running within guest operating systems, no per VM maintenance, no version mismatches to manage. The protection operates externally, interacting at the hypervisor level rather than relying on in-guest components. For MSPs, this significantly simplifies deployment. You don't need to coordinate agent installs across dozens or hundreds of VMs. You don't need to troubleshoot guest-level conflicts. And you reduce the operational footprint inside production workloads. Agentless protection keeps the virtual machine clean while still enabling full image-based recovery. And that operational simplicity becomes even more valuable as environments scale. Agentless protection is not only about simplicity, it's also about performance. Because no agents run in each virtual machine, there is no additional guest-level CPU or memory consumption associated with backup operations. Backups occur externally, reducing the impact on the workload itself. In production environments, that matters. Applications need predictable performance. Databases need stable I/O. Customer-facing systems cannot tolerate unnecessary overhead. When backup processes introduce variability, it can be difficult to distinguish between application performance issues and protection-related activity. Agentless backups reduce this risk. It keeps protection activity controlled and external while still capturing full system images. For MSPs managing client SLAs, minimizing operational overhead is not optional. It's essential. Proxmox is often deployed in clustered configurations. Workloads can migrate between hosts. High availability features redistribute virtual machines. Infrastructure scales horizontally. In that type of environment, backup behavior must remain consistent, regardless of which host a workload is running on. Agentless protection allows for that consistency. Because the backup model is not dependent on in-guest components tied to specific machine, workloads can move within the cluster without disrupting the protection strategy. Whether a virtual machine resides on host A today or host B tomorrow, the backup process remains predictable. For MSPs, this eliminates another layer of operational complexity. You're not tracking agent placement, you're not adjusting protection policies to account for VM migrations, and you're not troubleshooting inconsistencies across nodes. Cluster mobility does not disrupt backup consistency. And that scalability is what makes agentless protection particularly well suited for modern Proxmox environments. Backup only matters if recovery works. ActiveImage Protector allows you to restore protected systems directly into Proxmox. That means when a virtual machine fails, whether due to corruption, hardware failure, ransomware, or administrative error, you can recover it back into the Proxmox environment as a functioning virtual machine. You are not reconstructing the system manually. You're not reinstalling the operating system. You're not rebuilding application stacks. You are restoring the complete image. The result is a system that comes back in the state it was at the time of backup. Configuration, applications, and data intact. For MSPs, this dramatically reduces the recovery time and uncertainty. The restore process is controlled, predictable, and aligned with the same image-based model used across other platforms. And that consistency is what makes recovery be manageable under pressure. In production environments, recovery speed matters, but speed without predictability is not enough. A fast restore that fails halfway through or produces an unstable system doesn't help during an outage. ActiveImage Protector is built around full system image recovery, which allows restoration to follow a structured, repeatable path. The restore process is not improvised. It is not dependent on reconstructing components manually, and it does not require rebuilding systems piece by piece. You restore the image, you bring the system online, you validate, and you return it to service. That structured recovery path is what reduces uncertainty. For MSPs, predictable recovery timelines support SLA commitments. For enterprises, it reduces downtime impact, and for technical teams, it lowers stress during incidents. When recovery is consistent, confidence increases, and confidence is what makes protection sustainable. Recovery into Proxmox is not limited to a single protection method. ActiveImage Protector supports both agentless and agent-based backups, and recovery works with either approach. In many Proxmox environments, agentless protection will be the preferred model. But there are scenarios where agent-based protection is appropriate. For example, specific application consistency requirements or physical systems being protected alongside virtual machines. Regardless of how the backup was created, the recovery process remains aligned. You are restoring a complete system image, you are bringing that system into Proxmox as a working virtual machine, and you're following the same structured recovery workflow. That flexibility matters in mixed environments. It allows organizations to standardize on a single recovery philosophy, even when protection methods may vary. And with recovery fully covered, we can now broaden the conversation to something equally as important: migration flexibility. Recovery flexibility doesn't stop at Proxmox. Because ActiveImage Protector captures full system images, those images are portable. A virtual machine running on Proxmox today can be restored to physical hardware if necessary. This may not be the most common scenario, but it is an important one. In certain recovery situations, physical hardware may be the fastest available path to bring a system back online. In other cases, organizations may need to temporarily shift workloads due to infrastructure constraints. The key point is this: the backup is not tied to the original virtualization layer. The image represents the system itself, not just the platform it ran on. That portability gives organizations options during recovery and migration events, and options are what reduce risk. The flexibility works in both directions. Physical systems can be restored directly into Proxmox as virtual machines. This is particularly valuable during modernization efforts. Many organizations still operate physical servers running legacy applications for infrastructure services. Rebuilding those systems manually inside a virtual platform can be time-consuming and risky. With image-based protection, that rebuild process isn't necessary. You protect the physical system as a complete image, then restore that image into Proxmox as a virtual machine. The operating system, applications, configurations, and data are preserved. This approach simplifies physical to virtual migration dramatically. For MSPs, it allows legacy systems to be consolidated into virtual environments without extended downtime or complex reconfiguration. And it turns what could be a multi-step migration project into a structured recovery process. The real advantage of cross-platform recovery is not just flexibility, it's consistency. Whether you are restoring a Proxmox virtual machine back into Proxmox, moving it to physical hardware, or bringing a physical system into a virtual environment, the workflow remains fundamentally the same. You select the image, you define the target, you execute the restore, you validate the result. The underlying infrastructure may differ, but the recovery model does not. For MSPs, this consistency simplifies training and documentation. For enterprises, it reduces operational friction during migrations. And during an outage, it lowers cognitive load when every minute matters. When the recovery process stays the same, even as platforms change, infrastructure modernization becomes far less disruptive. And that is what transforms backup from a defensive tool into a strategic enabler. Infrastructure is not static. Even in well-planned environments, platforms evolve over time. Licensing models shift, hardware reaches end of life, performance requirements increase, business priorities change. Very few organizations deploy a virtualization platform and leave it untouched for a decade. What we're seeing today with Proxmox is part of a larger pattern. Before that, organizations moved from physical to VMware, then from VMware to mixed hypervisors. Now, in many cases, from proprietary licensing models to more open platforms. The platform may change, but the need for protection does not. And if backup strategies are tightly bound to the current platform, every transition becomes more complicated than it needs to be. That's why migration must be assumed, not treated as an exception. Even when virtualization platforms remain stable, hardware does not. Servers reach end of life, storage arrays are replaced, performance demands increase, data center strategies evolve. Hardware refresh cycles are constant in modern IT operations. Every hardware refresh creates an opportunity and a risk. An opportunity to modernize, a risk if recovery processes are fragile or overly platform dependent. If backup and recovery are tightly bound to specific hardware or hypervisor configurations, infrastructure upgrades become more complex than they should be. But if protection is image-based and platform-independent, hardware refreshes become far more controlled. You protect the system, you restore it to new hardware or new platform, you validate, and you move forward. Modernization should not require rebuilding infrastructure from scratch, and it shouldn't require rethinking your entire backup strategy either. When you look at platform transitions and hardware refresh cycles together, a pattern becomes clear. Change is not occasional. It is continuous. Infrastructure evolves, licensing models shift, hardware ages, business priorities adjust. If backup strategies are built around the assumption that the platform will remain fixed, they eventually become friction points during modernization. But if backup strategies are built with change in mind, transitions become manageable. Protection should not be tightly coupled to today's hypervisor, recovery should not depend on yesterday's hardware, and migration should not require rebuilding systems manually. Backup strategies must assume change, because change is inevitable. When protection is portable, consistent, and platform independent, infrastructure can evolve without increasing operational risk. And that's exactly what we'll look at next as we move into specific migration scenarios. Let's look at a scenario many organizations are actively navigating today. Migrating from VMware to Proxmox. The first step in that process is not migration, it's protection. Before workloads are moved, they should be backed up in a way that preserves full system state, operating system, applications, configuration, and data. ActiveImage Protector allows you to protect existing VMware virtual machines as complete images. That means you're not converting first and hoping it works. You are securing the state of each system before making changes. For MSPs, this provides a safety net. If something goes wrong during migration, you're not troubleshooting blind. You have a recoverable, restorable image of the original system. Protection comes first, migration comes second. And that sequence dramatically reduces risk. Once the VMware virtual machine has been protected as a full system image, migration becomes straightforward. Instead of performing complex conversion processes first, you restore the protected image directly into Proxmox. The system boots inside the Proxmox environment as a working virtual machine, with its operating system, applications, and data intact. This approach changes the nature of migration. You're not reconstructing systems manually, you're not reconfiguring applications from scratch, and you're not juggling separate migration utilities alongside backup tools. You are executing a recovery operation into a new platform. For MSPs, this dramatically reduces migration complexity. Recovery becomes the migration. And because the workflow is consistent with the image-based recovery model used elsewhere, there's no need to introduce a separate migration process. One of the hidden complexities in many migration projects is tool sprawl. Organizations often find themselves running one backup solution for the old platform and another one for the new one, at least temporarily. That means duplicate licensing, duplicate monitoring, duplicate recovery procedures, and duplicate risk. With an image-based, platform-independent approach, that duplication is not necessary. The same protection platform that backs up VMware can restore into Proxmox. There is no need to maintain parallel backup systems during the transition. You're not migrating tools, you're not retraining teams mid-project, you're not maintaining separate recovery documentation for each stage of the migration. The backup strategy remains constant. Only the virtualization platform changes. And that stability is what makes large-scale migration far more manageable. Despite widespread virtualization, many organizations still run critical workloads on physical servers. These may be legacy applications, specialized systems, or infrastructure services that were never migrated. Before modernization begins, those systems need protection. ActiveImage Protector can back up physical servers as complete system images, just as it does with virtual machines. That means operating systems, applications, configuration, and data are captured together. This is important because modernization projects often start with protection. You don't migrate first and hope nothing breaks. You secure the system's current state, you validate the backup, and only then do you proceed with transition. For MSPs, this provides a controlled path forward. Physical systems are no longer obstacles, they become candidates for structured migration. And that's where the next step comes in. Once a physical system has been protected as a full image, virtualization becomes a recovery operation, not a rebuild. The protected image can be restored directly into Proxmox as a virtual machine. There is no need to reinstall the operating system, no need to manually migrate applications, no need to reconfigure services from scratch. The system is restored in its entirety. Operating system, applications, configuration, and data now running inside the Proxmox environment. This dramatically simplifies physical to virtual migration. Instead of planning lengthy rebuild projects, you follow a structured recovery process. For MSPs, this reduces downtime, minimizes risks, and avoids fragile steps that often accompany manual migration efforts. Modernization becomes controlled and repeatable, and that makes even legacy infrastructure manageable. One of the biggest barriers to modernization is the fear of disruption. Legacy applications may not have installers, configuration details may be undocumented, original architects may no longer be available. Redesigning workloads from scratch is time-consuming and risky. Image-based migration changes that equation. When you protect a physical system as a complete image and restore it into Proxmox, you are not redesigning the workload. You are relocating it. The operating system, applications, and configurations remain intact. Modernization happens at the infrastructure level, not at the application level. For MSPs and enterprise teams, this reduces project scope dramatically. Instead of rebuilding systems one component at a time, you follow a structured protection and restore workflow. and that allows organizations to modernize confidently without rewriting their operational history. Recovery flexibility doesn't end with physical and virtual infrastructure. Proxmox workloads can be restored into supported cloud platforms. Because ActiveImage Protector captures full system images, these images are portable beyond the local data center. If a disaster affects on-premise infrastructure, whether due to hardware failure, environmental issues, or extended outages, protected systems can be brought online in the cloud. This is not about redesigning applications to be cloud native. It's about preserving business continuity. You protect the system as it exists, you restore it into a cloud environment, you validate, and you return services to operation. For MSPs, this provides another recovery target without introducing a separate protection framework. The backup model remains consistent. Only the recovery destination changes, and that optionality is what strengthens resilience. Cloud recovery is not theoretical. ActiveImage Protector supports recovery into platforms such as Oracle Cloud Infrastructure and Google Cloud Platform. These environments provide scalable infrastructure that can be used for disaster recovery scenarios, temporary failover, or long-term transition strategies. The key point is compatibility. Protected system images can be restored into supported cloud environments without requiring a different backup workflow or separate protection platform. You're not exporting partial data. You're not reconstructing services manually. You're restoring full system images, just as you would on physical or virtual infrastructure. For MSPs managing geographically distributed clients, this provides an additional layer of resilience. For enterprises, it enables disaster recovery planning that extends beyond the primary data center. And because the recovery process remains consistent, cloud becomes another controlled option, not a separate operational model. Cloud recovery is most valuable when it serves a clear purpose. One of those purposes is disaster recovery. If on-premise infrastructure becomes unavailable due to hardware failure, environmental events, or extended outages, protected Proxmox workloads can be restored into the cloud to maintain continuity. The cloud becomes a recovery target, not a redesign project, not a re-architecture initiative, but a controlled restoration environment. Another practical use case is transition. Organizations may use cloud recovery as an interim step during data center consolidation, hardware refresh cycles, or platform migrations. Instead of maintaining duplicate infrastructure locally, workloads can be brought online in the cloud temporarily while modernization proceeds. In both scenarios, the backup strategy remains the same. The recovery workflow remains the same. Only the destination changes. And that consistency is what makes cloud recovery manageable rather than disruptive. In most production environments, platforms overlap. Even after adopting Proxmox, VMware may still support legacy workloads. Hyper-V may still be present in certain departments. Cloud instances may run alongside on-prem infrastructure. Very few organizations operate a clean, single hypervisor world. Transitions take time. Legacy systems remain. Client requirements vary. For MSPs especially, mixed environments are the norm, not the exception. And that coexistence is not a problem. It only becomes a problem when protection strategies fragment alongside the platforms. The goal is not to eliminate diversity in infrastructure. The goal is to manage it without increasing operational risk. And that's where consistency becomes critical again. Even in highly virtualized environments, physical systems still exist. Some may support legacy applications. Some may host specialized hardware integrations. Others may simply have not been migrated yet. Physical infrastructure does not disappear overnight. For MSPs, this is especially true. Client environments are rarely uniform. Budget cycles differ. Technical constraints vary. And that means backup strategies must accommodate both physical and virtual systems simultaneously. If protection is limited to a single virtualization platform, physical systems become outliers. But if protection is image-based and platform-independent, physical systems fit naturally into the same recovery model. They are protected the same way, restored the same way, and managed under the same operational framework. And that alignment reduces complexity significantly. When virtualization platforms overlap and physical systems remain in production, the simplest and most resilient approach is consolidation at the protection layer. One backup and recovery platform across Proxmox, across VMware, across Hyper-V, across physical infrastructure, across cloud targets. The infrastructure may vary, the hypervisors may change, the hardware may evolve, but the protection model remains unified. For MSPs, this reduces tool sprawl, it simplifies training, it standardizes documentation, and it lowers the risk of mistakes during incident response. For enterprises, it provides architectural clarity. Instead of aligning backup strategy to each platform individually, you align it to the workload itself. And when the protection model remains consistent, infrastructure can evolve without multiplying operational complexity. That consistency is what turns mixed environments from a liability into something manageable. When discussing virtualization security, it is important to separate concerns. Ransomware does not typically target the hypervisor itself. It targets data. More specifically, it targets systems and the backups that protect them. Whether workloads run on Proxmox, VMware, or physical hardware, the attack surface is usually the same: operating systems, applications, credentials, and accessible storage. Virtualization does not eliminate ransomware risk. It changes how systems are structured, but it does not remove exposure. And in many cases, attackers intentionally look for backup systems because they know those systems represent the last line of defense. If backups are accessible, they are vulnerable. That's why protection strategies must include architectural safeguards, not just platform features. And that brings us to the next critical point. In many ransomware incidents, the attacker's final objective is not just to encrypt production systems, it is to eliminate recovery options. Backup systems are often targeted deliberately. If attackers can locate repositories for backups, access backup storage, or encrypt backup data, the organization loses its fastest path to recovery. This is not specific to Proxmox. It applies to any environment. The hypervisor may be stable. The workloads may be clustered. High availability may be functioning. But if backup storage is exposed to the same network as production systems, it shares the same risk profile. That's why backup architecture must include deliberate isolation. Not just authentication, not just permissions, but architectural separation that reduces exposure. And that leads directly to the next layer of protection. Security risk often increases during periods of change. Platform migrations, hardware refreshes, temporary mixed environments, parallel infrastructure during transition. These moments introduce complexity, and complexity is where exposure tends to grow. Temporary network paths are created, backup storage may be shared across platforms, access controls are adjusted, new systems are brought online quickly. During these transitions, it becomes easier for security assumptions to drift. If backup architecture is tightly coupled to the current platform, transitions can introduce blind spots. But if protection is architected with isolation and portability in mind, the backup strategy remains stable, even when infrastructure is in motion. Security should not weaken during modernization. It should remain consistent. And that consistency depends on architectural decisions, not just platform capabilities. Which brings us now to how backup isolation can be implemented deliberately. One of the most effective ways to protect backups is simple in concept. Remove their exposure. With ActiveImage Protector, backup storage can be automatically isolated once a backup job completes. That means the backup repositories are not persistently accessible on the production network. They are connected when needed and disconnected when not. This significantly reduces the window of exposure. If ransomware compromises a production system, it cannot reach backup storage that is not continuously mounted or accessible. This is architectural protection. It does not rely solely on permissions or policy enforcements. It reduces the attack surface by design, and that distinction is critical in modern environments. Persistent network exposure is one of the most common weaknesses in backup architecture. If backup storage is continuously accessible from the same network as production workloads, it shares the same risk surface. Compromised credentials, lateral movement, automated encryption routines, all of these threats depend on access. By eliminating persistent network exposure, you dramatically reduce that risk. Backup should not behave like shared production storage. It should not be browsable. It should not be mounted indefinitely, and it should not be reachable unless a backup or restore operation requires it. When backup repositories are only accessible during controlled operations, the attack surface shrinks significantly. And that architectural separation is far more reliable than assuming credentials will never be compromised. At the end of the day, the strongest security controls are architectural. Policies can be misconfigured. Credentials can be compromised. Permissions can drift over time. But architecture is structural. When backup storage is designed to be isolated by default, when it's not persistently exposed, not continuously mounted, and not casually reachable, you are reducing risk at a foundational level. This is protection by architecture, not by assumption. It does not depend solely on administrators remembering to follow procedures. It does not depend entirely on password strength. It reduces exposure through design. In Proxmox environments, especially during migrations and mixed platform operation, that architectural discipline becomes even more important. Because infrastructure may evolve, but protection should remain deliberate and resilient. Now let's step back and look at the architecture as a whole. In a Proxmox environment, ActiveImage Protector performs agentless backup directly from the Proxmox hosts. There are no agents inside each virtual machine, no guest-level dependencies, no per-VM deployment overhead. The protection model interacts at the hypervisor level, capturing full system images of the workloads running within the environment. This keeps the guest systems clean, it minimizes operational friction, and it centralizes protection activity at the infrastructure layer. From an architectural perspective, this reinforces everything we've discussed. The hypervisor runs workloads, the protection platform secures them, and the two operate independently but cooperatively. That separation of responsibilities is intentional. It keeps virtualization focused on performance and availability, while backup focuses on recovery and resilience. Beyond agentless protection at the host level, management is centralized. Backup policies, scheduling, retention rules, and recovery operations are coordinated from a unified management layer. This eliminates fragmentation. You're not managing separate backup tools per hypervisor. You're not juggling isolated configuration sets. You're not maintaining different recovery consoles for different platforms. Protection is orchestrated from a central point. For MSPs, this simplifies multi-client management. For enterprises, it improves visibility and control across distributed infrastructure. Centralization also supports standardization. Backup policies can be applied consistently. Verification processes can be enforced uniformly. Recovery documentation can follow a single operational model. And that consistency is what allows complex environments to remain manageable. One of the defining characteristics of this architecture is flexibility in recovery targets. The protected system image is not bound to a single destination. Once a workload is captured as a full image, recovery can be directed wherever operational needs require. That may be back into Proxmox, it may be to physical hardware, or it may be into a supported cloud platform. The key point is this: the backup represents the system, not the platform. That architectural decision is what enables flexibility without introducing additional complexity. Recovery remains structured, the workflow remains consistent, only the destination changes. And now let's look at those recovery targets one by one. Within this architecture, recovery can occur directly back into Proxmox. That is the most immediate and often most common recovery path. If a virtual machine fails, is corrupted, or is compromised, the protected image can be restored into the Proxmox environment as a working virtual machine. The workflow is structured and repeatable. You select an image, you define the Proxmox host or cluster target, you initiate recovery, you validate. The recovery path is direct and predictable. There is no conversion detour, no secondary migration tooling, no manual reconstruction. From an architectural standpoint, Proxmox is a first-class recovery target, and that clarity reinforces the confidence organizations expect in production environments. Recovery flexibility does not stop at the hypervisor. In addition to restoring back into Proxmox, the same protected image can be recovered to physical hardware. This is important in several real-world scenarios. If virtualization infrastructure is unavailable, physical hardware may provide the fastest path to restore critical services. In other cases, organizations may need to temporarily shift workloads due to resource constraints or hardware transitions. Because the backup is image-based and platform-independent, the restore workflow remains consistent. You're not converting formats, you're not rebuilding systems manually, you're not introducing separate recovery tools. You're restoring the system image just to a different target. That portability gives organizations options, and options are what reduce risk during outages and migrations. At the architectural level, recovery flexibility spans the full spectrum of infrastructure: Proxmox, physical hardware, and supported cloud platforms. The same protected system image can be restored into any of these environments depending on operational needs. That flexibility transforms backup into something more than a safety mechanism. It becomes an enabler of modernization, an enabler of disaster recovery planning, and an enabler of infrastructure evolution. The recovery workflow remains consistent, the production model remains unified, only the destination changes. For MSPs, this means you can support diverse client environments without multiplying operational complexity. For enterprises, it means infrastructure decisions can evolve without destabilizing protection strategy. The architecture supports movement, and that is what allows organizations to modernize confidently without compromising resilience. All of this architectural flexibility ultimately translates into something very practical: one backup and recovery platform. Instead of maintaining separate tools for Proxmox, VMware, physical servers, and cloud workloads, protection is unified. You're not switching consoles, you're not maintaining separate documentation sets, you're not retraining technicians for every platform. The operational model remains consistent. For MSPs, this reduces tool sprawl. It simplifies onboarding, and it lowers the cognitive load during incident response. For enterprises, it improves governance and visibility. Day to day, the goal is not complexity, it's predictability, and a unified backup platform is what makes that possible. Consistency is what makes operations sustainable. When workflows remain the same across Proxmox, VMware, physical systems, and cloud targets, teams build confidence through repetition. Backup scheduling follows the same model. Verifications follow the same logic. Recovery follows the same structured process. Technicians are not forced to remember different recovery paths depending on where a system resides. Under pressure, during outages and security incidents, that consistency becomes critical. When a workflow is familiar, decisions are faster, mistakes are fewer, and recovery is more controlled. For MSPs managing multiple clients, this consistency scales. For enterprises managing distributed infrastructure, it stabilizes operations. The environment may be mixed, but the workflow remains unified. At the end of the day, the real benefit is reduced operational complexity. Not more features, not more tools, not more dashboards, less friction. When protection is platform independent, you eliminate unnecessary duplication. When recovery workflows remain consistent, you reduce cognitive load. When backup architecture includes isolation and portability by design, you reduce the risk during transitions. And when the migration becomes a recovery operation rather than a rebuild project, modernization becomes manageable. For MSPs, this translates into fewer moving parts and clearer procedures. For enterprises, it means infrastructure can evolve without multiplying operational overhead. The goal is not to make environments simpler, because real-world environments are rarely simple. The goal is to make protection simpler, and that's what ultimately changes day-to-day operations. To make everything we've discussed concrete, let's walk through a short demonstration. We'll begin with an agentless backup of Proxmox virtual machine. This will illustrate the operational simplicity we've been describing. No in-guest agents, no per VM deployment overhead, and no disruption to the running workload. You'll see how the backup is initiated, how it interacts with the Proxmox environment, and how the system is captured as a complete image. The goal here is not to explore every feature. It's to reinforce the architectural model, hypervisor level protection, full system image capture, controlled and repeatable workflows. Once we've completed the backup, we'll move directly into recovery. Now that the backup has been completed, let's move directly into recovery. We'll restore the protected image back into the Proxmox environment. This demonstrates the core principles we've discussed throughout this session. Recovery is structured, recovery is predictable, recovery is not a rebuild. You'll see how the image is selected, how the Proxmox target is defined, and how the system is brought online as a functioning virtual machine. The restore process mirrors the architectural model we've described. It does not depend on separate migration utilities. It does not require manual reconstruction. It follows a consistent workflow. The objective here is clarity. Backup and recovery should not be complex under pressure. They should be deliberate, repeatable, and controlled. After this restore completes, we'll briefly look at cross-platform recovery flexibility. To close the demonstration, let's briefly look at cross-platform recovery. The same image we just restored into Proxmox is not limited to that destination. It can also be restored to physical hardware or to supported cloud platforms. The workflow remains the same. You select the image, you choose the target, you execute the restore. This reinforces the architectural principle we've discussed throughout this session. The backup represents the system, not the hypervisor. That portability is what enables migration, disaster recovery planning, and infrastructure modernization without introducing additional tools or workflows. The demo you've just seen is not a special case. It's the same model applied consistently across environments. And that consistency is what makes the architecture sustainable. Let's briefly summarize what we just demonstrated. First, you saw an agentless backup of a Proxmox virtual machine. There were no guest agents installed inside the virtual machine. The protection occurred at the hypervisor level, capturing a full system image without adding additional overhead inside the workload. This reinforces the architectural separation we've discussed earlier. Proxmox runs the workload, ActiveImage Protector secures it. The two operate independently but cooperatively. The backup process was controlled, structured, and repeatable. And that simplicity is intentional. Second, you saw recovery directly into Proxmox. The protected image was restored into the Proxmox environment as a functioning virtual machine. There was no manual reconstruction, no conversion detour, no separate migration tooling. The recovery followed the same structured workflow we've been describing throughout the session. Select the image, define the target, execute the restore, validate. That predictability is what matters in production. It reduces uncertainty, it supports SLA commitments, and it gives technical teams confidence during incidents. This restore was not a special case scenario. It was a straightforward execution of the architectural model. Finally, what you saw was consistency. The backup model did not change based on the platform. The recovery workflow did not change based on the destination. Whether restoring into Proxmox, to physical hardware, or into a cloud environment, the process remains aligned. That consistency is what makes the architecture practical. It reduces our operational fragmentation, it lowers cognitive load, and it allows infrastructure to evolve without forcing teams to relearn recovery procedures. The demonstration was not about individual features. It was about validating the model. A unified, image-based protection strategy remains stable even as platforms change. And that is the foundation for the final key takeaways. If there is one thing to reinforce at this point, it is this. Proxmox is production ready. It is built on mature KVM technology. It supports clustering, high availability, and modern virtualization features. And it is actively deployed in enterprise and MSP environments. The question is no longer whether Proxmox can run production workloads. It can. The real question becomes how to protect those workloads in a way that supports migration, modernization, and security. And that's where the remaining takeaways come in. If platforms evolve, and they always do, then backup strategies must remain platform independent. Virtualization technologies change, licensing models shift, hardware refresh cycles continue, cloud adoption expands. If protection is tightly coupled to a single hypervisor, every transition increases operational risk. But when backup is image-based and platform independent, infrastructure can evolve without destabilizing recovery strategy. You are protecting the workload, not the platform. That distinction is what enables migration. It supports modernization, and it strengthens resilience during transitions. Proxmox may be production ready, but production resilience depends on protection that is not limited to a single environment. Modernization and resilience are often treated as opposing forces, Modernization implies change, resilience implies stability. But they do not have to conflict. When protection is portable, consistent, and architected deliberately, infrastructure can evolve without increasing operational fragility. Organizations can migrate from VMware to Proxmox. They can virtualize physical systems. They can extend recovery into the cloud. They can refresh hardware. All throughout these transitions, recovery workflows remain stable. That is the balance. Modernize the platform, stabilize the production layer. When those two principles align, change does not increase risk. It becomes manageable. And that's the real takeaway. This approach tends to resonate most with a few specific types of environments. Organizations planning or are already moving from VMware to Proxmox, teams running mixed hypervisors, sometimes longer than expected, and MSPs who need a consistent way to protect very different client infrastructures. If change is part of your roadmap, this model fits naturally. This approach also benefits environments running mixed hypervisors. In reality, transitions rarely happen overnight. VMware, Proxmox, Hyper-V, and physical systems often coexist longer than originally planned. In these mixed environments, fragmentation becomes the real risk. When different platforms require different protection tools, operational complexity increases. A unified backup strategy keeps recovery workflows consistent, even when infrastructure is not. If your environment includes multiple platforms, consistency at the protection layer becomes critical. For MSPs, this model becomes even more practical. Client infrastructures vary widely. Some may run VMware, others may adopt Proxmox, some may still operate physical systems, others may extend into the cloud. Managing separate backup tools across these environments increases overhead and risk. A single platform for backup, recovery, and migration simplifies operations across diverse client bases. If you support multiple environments, a unified protection strategy reduces complexity while maintaining flexibility. And if change is part of your roadmap, whether internal or across clients, this model fits naturally. If you'd like to explore this further, there are a few straightforward next steps. We provide detailed product documentation and technical resources that outline architecture, deployment, and operational guidance. These materials are designed to help technical teams evaluate and plan implementation with clarity. In addition to documentation, we offer architecture and migration guidance. Whether you're evaluating a VMware to Proxmox transition, consolidating mixed environments, or planning modernization initiatives, the Actiphy team can help align protection strategy with your roadmap. The goal is not simply deployment, it's long-term operational stability. If you prefer to see how this works in your own environment, you can request a trial, an evaluation, or a live technical demonstration. This allows your team to validate workflows, test recovery paths, and confirm alignment with your operational requirements. Seeing the process inside your own infrastructure often provides the clearest understanding of its practical value. That brings us to the end of today's session. Thank you for taking the time to join us. We truly appreciate it. If you have questions, we'd be glad to discuss them. And if you'd like to follow up after the session, the Actiphy team is always available to assist with evaluation, architecture planning, or technical guidance. We look forward to continuing the conversation.